In the last video, I was describing the differences between using ethoxide and LDA in Claisen reactions. And the bottom line message was that as long as you use at least half an equivalent of ethoxide, you can use more and you'll still get the same product. You can use up to 2 equivalents, more even, of ethoxide, and you'll get the same deprotonated beta-ketoester product. The reason for this is ethoxide is not a strong enough base to quantitatively deprotonate the starting ester, and as a result, you only get a small amount of the enolate at any one time. There's plenty of ester left over. Even if you add an excess of that ethoxide, you still will have enough ester for the enolate that you do make to react to create the beta-ketoester deprotonated enolate product. Well, the case is very different when it comes to LDA. LDA can essentially quantitatively convert 1 equivalent of ester into 1 equivalent of enolate. There's now no ester left over in that reaction, so adding a full equivalent means all we end up with is an enolate and no Claisen reaction. And it all has to do with the difference in base strength, where LDA can quantitatively deprotonate the ester, but the ethoxide can only make a small amount of the enolate at any one time. Okay, the reason I'm making the second video is I had an error of omission. I made a mistake. What I want to do is I want to draw your attention to this chemical equation. It's not balanced. I'm going to give you a second to look at it and think about what's wrong here. I didn't do this on purpose, but I noticed it before I posted the video. Okay, what I want you to notice is that we have 1 full equivalent of that portion of the ester. But when we look at the product, there is only half an equivalent. Where's the rest of it? Well, I want you to think through the reaction mechanism and think, what did I not show that takes into account the other half equivalent of the piece of that ester? Okay, here's the answer. Here we are with the way I should have written the equation. Notice there is half an equivalent of ethanol produced in this process. That's what I left out. This equation is entirely balanced. Now, I pause there because I want you to think through where that came from. So I'm going to leave it as an exercise for yourself to think through what happens when you add half an equivalent of LDA to an ester to carry out a Claisen reaction. What are all the different pieces that are produced that allows you to balance the final equation? So I'll leave that up to you. I'll be glad to talk about it in office hours or the review session or class. But I wanted to point it out. So when you think about this reaction, I want you to look at this video and say, okay, on the last video, I left out this half equivalent of ethanol. And that's a key indicator of how the mechanism works. So I've corrected my mistake, and best of luck on the exam.